Okay, we continue now with Lena Viktorsson from the Baltic Eye project. And Lena's task will be very easy, to boil down all the presentations you have heard so far in nice take-home messages. So it is really an easy task to do. And please, Lena, the floor is yours.
Thank you for this introduction, Christoph. I'm not sure it will be that easy, but I will do my best. It said perspective in the schedule, so I will try to put perspective to the methods we've heard, and also in some way say something about what role could sea-based methods have for counteracting eutrophication or decreasing the symptoms. I will do this by summarizing and try to put the framework to the different methods, characterize them. But before we go into the perspectives, I will take just one step back. And I think eutrophication is man-made, so the solution to it will also be man-made. That's important to remember here. And there are, as I see it, 3 levels where we can work with decreasing eutrophication. And the first 2 here are the ones that also has created the eutrophication. First level, as I see it, is lifestyle and society and changes to that. But do we want to eat less hamburgers, fly less from Copenhagen, or change the life of the farmer in Broby? The second one is the one that we all agree that we need to do and are putting a lot of effort and money into, and that's reducing the input from the land to the sea. Structural liming, wetlands, and reducing fertilizer on fields. And the third one is the end of the pipe that we're talking with here. Can we do something with what's already in the water? Here we see from Trelleborg that we've all heard about, the production of biogas from algae that's in the water, so bringing back nutrients to land. And before we go in further and continue to talk about these sea-based methods, I think it's important that we remember that there's a general agreement that we need to reduce the input from sea to land, and we've already come very far. But this is something we can't let go of. We need to continue to keep the input from land to sea at least the levels we have today, and have an aim to reach the goals set by the Baltic Sea Action Plan. And if we don't do that, we have a saying in Sweden that it would literally be like throwing the money into the sea. And if we don't do these land nutrient reductions, we could as well just throw the money down the drain, as they say in English. So to structure these methods, I've divided them into 3 types. The first here is removal, and then I mean complete removal of, and then we talk about phosphorus in these 2 cases. Oxygenation, that we've heard both from Anders Stigebrandt and from Joni and Heikki on different scales. The intention is to take away phosphorus entirely from the ecosystem, and in this way decrease eutrophication and plankton growth. And the other one is precipitation, that we've also heard 2 different methods, the aluminum treatment and the lab experiments in using calcium for precipitation of phosphorus, and then bury it in the sediment so that it never returns to the production and recycling chain. And then we heard briefly about biomanipulation, or changes in zooplankton-eating fish and production by sieve. And then the majority of the methods here, they deal with recycling. And then that is taking nutrient that is in the sea and bringing it back to land and use it again. And for these, I think it's important to remember that they're all based on some kind of economic model. I mean, they do produce a product that there needs to be a market for selling this, or someone that wants to use this nutrient that's taken back again. So that's a little bit of the difference between this majority of these small-scale methods compared to the precipitation and oxygenation. I also think we need to think a little bit about the feasibility of using material from the sea as fertilizer compared to using livestock manure for fertilizer, a product that is, of course, suitable for fertilizer and that is already on land and is also increasing in production as meat production around the whole Baltic Sea is increasing. So that's something I think that we need to think about with these methods. So now I'll go into the different perspectives. I will talk about scale, potential, and then I talk about removal potential, the risks, costs, and the time perspective. And I will start with the scale perspective, which I think here is maybe the most important one to consider. And I think actually that the rest of these scales are determined a little bit about what scale we're talking about. We evaluate the costs, the risks, and the aim differently depending on what scale we're looking at. And we've heard today both about large-scale methods and small-scale coastal methods. And it's sometimes thought that it's not possible to do so much in the coastal areas because of the influence of the open sea conditions and the nutrient status that is there. And that is true for some areas. Open beaches and coasts are heavily influenced by conditions in the open sea, but there are also a lot of other type of coastal areas, like Björne Bay that Elin and Linda talked about, that is a very enclosed bay and has a limited exchange with the water outside. Then it's very much influenced by the local catchment area. And that type of bays are quite abundant around the Swedish and Finnish coast especially. So I think one of the potentials with the large-scale methods is that there are actually a lot of places around the Baltic Sea where we have these signs of eutrophication and very low oxygen conditions also close to the coast and not only in the open sea. And the potential here, I think, also lies within working with the local community and showing something to the people that are living by the coast, visiting the coast, that we can do something and we can improve the environment here. For some of the areas, you do need to remember that they will, to some extent, always be influenced by the sea outside. So these type of measurements on the local scale, in time perspective-wise, you would need to think that you probably need to continue with these methods until you've solved the large-scale eutrophication problem. And therefore, it is utterly important to keep focus also on reducing the input from land. Otherwise, we will forever have to use these sea-based measures to kind of keep up the system if we don't reduce the inputs. So then, what maybe is more often thought about with eutrophication in the Baltic Sea, the large-scale anoxia and the increasing cyanobacteria blooms. And I would say with this open sea potential, it is, we have the two methods, oxygenation and precipitation. Of course, some of the other smaller scale methods could also, as Linda and Emil said, they could be upscaled, but that is on a maybe longer time scale and will go stepwise through smaller areas. And with these two that are the removal type from the first categorization I made, I think one of the largest potentials with them is that they target the phosphorus, oxygen, and eutrophication or primary production connection between these and target those links to try to stop this feedback that we learned about also in the morning. And also one strength with targeting the open sea or the large scale is that the large scale will also improve much of the coastal zone, or the open coastal zones, so to say, that are not these enclosed bays will also be improved. And of course, especially with oxygenation, we have this strength that it opens up for recolonization by animals from the the areas and volumes that are now anoxic and where no life is living. But there are also some greater risks or uncertainties when you go from these large-scale bay projects to look at the open sea. And that is natural. We're moving from something that we feel that we maybe can control. We can view the whole bay maybe for some times, or maybe bike around it, and it feels like it's controllable. And there are commonly fears or around when you talk about manipulating the ecosystem. And when we talk about these risks, I think it's important to remember, like Christoph said in the very beginning, that we are already manipulating the ecosystem in many ways. The difference is that we do these things to gain something immediately. We fish because we need food. We construct hydropower and wind power because we need energy for our society. We do constructions because we don't want to have a jet eye where we can put our boat, or a bridge to Öland, or something like this. And we ship all the goods and services around that we need. So when you think about the risks and the legal framework for this, I think you should have this perspective that we're already actually doing something, and this time we're trying to do something to make it better. Just remember that when you talk about it. It doesn't mean that there is no risks or no uncertainties with this. And of course, all the different projects, both large scale and small scale, needs to be evaluated, at least according to the existing legal framework for the environment. And for when you go to large scale, I mean, you see with fisheries, there is some difficulties with the legal framework there as well. So when you go to these things that affect the entire ecosystem, there are things that you really need to put some thought in. And then shortly also about the risks and about oxygenation especially, because that is one of the points I think that are most commonly brought up when you talk about these sea-based methods and going in and doing something in the sea. But isn't there big risks with mixing the whole water in the Baltic Sea? And I think there, of course, needs, just like Anders said when he presented his project, that we need to make a complete environmental impact assessment, very thorough, before we can implement anything like this. And here there are certain things that I think it needs to put special emphasis on, and that's we don't know for sure yet about the long-term effects of oxygenation, even though we can see what happens when there's an inflow and the water is oxygenized. Generally, when it's oxic, there's lower phosphorus concentrations, but that's for a short period of time, and then it becomes anoxic again. So what happens on a longer time scale? Do we really remove the phosphorus permanently if we oxygenate for 10 years or 15 years or 50 years or whatever the time frame will be? There's also questions regarding what will happen to the nitrogen cycling that needs to be further looked into. And also this that I said as one of the potentials, recolonization by animals. That's also one of the risks or obstacles with it that we need to answer. What happens when new animals starts digging in the sediment? How does that affect the nitrogen and phosphorus cycling? Does it release more or less? Or does it release more of one and less of the other? How does it work? And of course, the cod. That's one of the general concerns. We do something in the Baltic, it needs to be good for the cod. And they will, of course, be happy if there's oxygen. Then they can swim around and survive in new waters. But they also need a certain salinity, because otherwise their eggs will fall down to the bottom and they will die and they won't be able to reproduce. And Anders has showed in his studies and modeling that yes, if we pump this certain amount, then we can achieve oxic waters and high enough salinity. But I don't think it's enough with one researcher doing this. Before we can implement this, of course, we need to look at other models, ensemble modeling, and put more, like Juni said in the presentations with small-scale oxygenation, further research is needed. So I think before taking the next step there, of course, we need to confirm these results, that it is actually possible to mix the water in this way. And then there's also, connected to this technical question, is it feasible to do this? How is it? There's several reports from the Boxwind project where they examine, can we pump in the Bornholm Basin? But that's also just from one group. Of course, we need to confirm these results. How big should the pumps be? How much do we need to pump? Where should they be put? And so on. There's legal issues. It's many countries around the Baltic Sea. Who will pay? Are they all interested? How do we solve that? And of course, also ethical questions. And there, I think, maybe a starting point for that could be to think, if we think this is something that we can do for the small scale, then maybe it's okay to do it for the big scale. Or what happens when we upscale it? Is it something that comes in and say, like, no, now it's not okay anymore? And what kind of moral issues is it around that?
Maybe what's the moral of non-doing?
Exactly, absolutely. And that comes in touches the time perspective that I will come to here in the very end. I think that's very heavily connected. Like, do we do only the land reductions that are planned, that we all agree that we need to do regardless? And then we have the time frame that Bo showed in the morning, about 75, 100 years or so until we can reach the goals of no eutrophication, or do we want to do something on top of that? And that fits good into the next slide here with cost and scale. So this will be rough estimations. I haven't put down the exact numbers, so we will see some comparison between the different types of methods. And I don't guarantee the exact names to the last euro here or something like this. But first here is the scale here means that land measures is basin-wide. This is something that affects the whole Baltic Sea and that we need to do for all of it. And this is estimated cost, more or less. Then we have the recycling methods, and they all intend to be in some way self-financed. The algae they were already taking up to have nice beaches during the summer, so they didn't have any extra cost. The retrieval of sediment is also supposed to be a self-financing process. So all those are, in that sense, low in cost, but they're generally also going for the smaller scale, improving the environment in a single bay or maybe 2 or 3 bays. Then we have precipitation, which, as we've heard, is now used on this smaller scale, just 1 bay, but can go further to other bays, and can likely also be upscaled to larger areas. And there, the costs are similar to the total cost of the land-based measures for the entire Baltic Sea. And the reason it's tilted is because we assume that it will probably be lower when you scale it up, because you need more aluminum, but the equipment will be the same for the next bay, so to say. And then we have oxygenation, which has a slightly lower cost, and we also here see that when we do it on the large scale, the cost will likely be lower than for just 1 separate bay. And then, as you mentioned, the time perspective. Here we see little Anton again, who is now running around, pulling his sister's hair. This was last summer in Skåne. And is this what he's going to see until he gets 50 years old and then start swimming in the water? Is this what his children is going to see or not? And when do we want to start doing something more than just the land reductions? And of course, it also matters the scale. Do we do it for just the base, or do we go for basin-wide? That was the perspectives. Now there will be coffee. But before you leave, there is also, I was asked to say that all the posters from the previous presentations, they are hanging out here. I heard there were some difficulties with some of the projectors, maybe not showing the colors very well. And there will also be meeting notes, and I think all the posters also will be sent available in a digital format for you afterwards.
Okay, thank you, Lena. Thank you. Okay, now is a coffee break.